your homework at some other point. So this one was just like the first one. We had a conjugate pair. So anything that you see plus or minus with a radical came from your quadratic. It's like you're working backwards. So if this is my quadratic, I want to work myself backwards to find what my equation was. To do this, in here, you're going to use your sum of your roots and your product of your roots. That's my mechanism to get this back to this, if you just give me the roots. This is my backwards in the door here. So you're going to have to, whenever you see that, use your sum and your product. So we have a sum and a product. Walk yourself backwards, find the equation that it came from, your quadratic, and all I had you do was just leave your factors there. Don't FOIL this out. Just leave it just like it is. I don't need this. I did this so that you would see this is what we've been starting with. We pulled up a factor such as 5. We factored it out. We did the quadratic, and we got this. We just took a backwards approach to this. This time I give you the roots, you give me the function. That's where this came from. That's if you could factor this, you wouldn't have to do any of your synthetic division. But we can't factor that. So that's where your synthetic division comes in. Now, these other parts, we started this one yesterday in class. I said you're going to have to find your roots. You have 3 zeros, 2 terms, 1 inflection. Your direction said you've got to find all the other parts to this thing. The only difference is this right here. That's the only difference between this and last week. Because now, if you knew your end behavior, down and up, and 3 zeros, we put it equal to 0, we find our zeros. This week we couldn't find the zeros. So we found 1 on your calculator, and we synthetically divided it out to find what was remaining. Once we get down to an x squared, it's factorable. Whether you can factor it or you use the quadratic. Don't be lazy. You have to put a lot of work into this. I didn't give you a lot of problems to do for that reason. So you do your quadratic and you come down to your other roots. Now you know approximately where your roots are. And yeah, I don't really know what this is, so let me take a guess at this. Radical 21, I can even put it in my calculator, but let's just do it without. Radical 21 is close to what radical that is a perfect square? 25, between 16 and 25. So even if I go with 25, that's a 5. Negative 5 plus or minus this. So negative 5 plus a little bit less than 5 divided by 2. Negative 5 plus 5 divided by 2. So you're here, say it's negative 10 divided by 2, you're here about negative 5. Say it's 0, you're very close to the 0. These are where your roots are coming from. You're very close to the 0 right in here. So, but you can see it on your calculator where your sketch goes. Your y-intercept, plug in your x is 0. So y is equal to 0 cubed plus 4 times 0 squared minus 4 times 0 minus 1. All of these come out. There's your y-intercept. You had to find your maximums. Are these relatives or absolutes? Relatives. You have a relative max and a relative min. This you have to find on your calculator 3 decimal places. You had to do your increasing, decreasing. You had 1 inflection, 3, 2, 1. Take your max and your min, your x values, find the average. There's your inflection point. And do your concavities. So the only thing different than your quiz from last week was our synthetic division. We couldn't factor this the way you factored it last week and find them with your, you know, when it's a nice little polynomial, we factored out the x, then we left with an x squared, and we can factor that. But you had to find all these pieces. Again, increasing, decreasing. Here's your increasing going up, decreasing, increasing. Your concavity, remember your concavity caves down, stops at the inflection, then caves up. Anybody not seeing this, not able to do this? No? Just lazy? Yep, yep. Okay. Let's go on to the next one. Since most of you don't have any of this one here. Now, I have three zeros, 2 turns, 1 inflection. Down on the left, up on the right. I cannot factor that. If I set it equal to 0, I can't factor it. So I pick up my calculator and I find the one root that I can. It's right here, 1, 0. Just take out 1, because once we use synthetic division, this comes to a quadratic, and a quadratic we can factor. Whether you factor it with your factors or you factor it with your quadratic, it'll come out to be the same thing, whichever you're able to factor it with. Or you complete the square, you can do that as well. Now, we were here, remember if you took 1 away, this has to start with an x squared. It has to have the 2. I have to find 2 more roots. That's what this 2 tells me. So quadratic, you find your 2 roots. Y-intercept, plug in x is 0. Show me the substitution. You know again, this is nice. The cubing function, domain and range are all real numbers. Relative max, relative min. Inflection point, take your relative, your max and your min, your x values, and take the average. It's a nice average. It came out to be 0. Anybody remember how I find the y value? Good. Put it in for value. Good job. Second calc. X equals, you do number 1 for value, x equals 0, and y will come back at -1. You need this one only because I want the inflection point. But your concavity is based on your x value. So your concave is coming from -infinity, stopping at the 0. Your concave up starts at 0 to infinity. Remember your increase, decrease, and your concavities work off your x values. Yeah, I'm going to have to just take this off here. That might be too big. Yeah, I'm going to be able to fit it on one screen. Is that better? Yeah. Okay. Okay, I think we got them all. All right, so make sure you find your roots. Your roots, one of them you have to find off your calc. Then do synthetic division till you get down to your x squared. If it was x to the 4th, you have to find 2 roots on your calculator. Get down to the x squared. See this one? Okay. Is this the last one? No. All right. This one we just did, right? This is the one we were on. Okay. This was a nice inflection point. It was easy to work with. Okay, good. All right, and the last one, it's an x to the fourth. All I know is I have 4 zeros, 3 terms, 2 inflections. My ends go up positive because I have a positive coefficient on my x to the fourth. And to get my roots, I have to look to my calculator. Now, you only see one out there, which is your 2 0. So you take out a 2. At this point, this is x cubed. You're kind of stuck. You can't do this again. You can't factor this. But if you notice, when you looked at your graph, it came and bounced off this positive 2. So what does that mean? What kind of root is that? A double. If it bounces off the x-axis, it's a double. So therefore, divide by 2 again. That means we had a multiplicity of 2. Two of those x equals would be a 2. So divide by 2 again until we can get down to an x squared. Now this is factorable. And you have to use your quadratic to factor this. Or you can use your complete the square. You can complete the square with this as well. This is a nice one for complete the square. Because this is a 1. Whoops, there wasn't 10. This is a 1. And this one's a nice even one. So you can use complete the square as well for that. So once you find all your parts, find your roots. Remember, this counts twice. So I have 2, 3, 4. One's a positive, one's a negative root. What are these pairs called again? Conjugates. Good. Notice they come from your quadratic equation, your formula. My y-intercept, plug in my zeros. There's my y-intercept, -4. Domain is all round numbers. These guys right down here, this is my absolute minimum down here. My absolute minimum. They're at the same point. So we're going to call this our absolute minimum. You need this point to find your range. It's a lot. It's a lot in one. But you have to do this. Yep, I'll move it down. Your inflection point, a little bit tougher. You have 2, 4, 3, 2 inflections. Take the average of your max and your mins. You had a relative max right here at your 2, 0. So that's going to help you get this inflection point right here, this guy, using this one and this one, and then use this one and this one to find that inflection point. And then your concavities. Your increasing, decreasing, and your concavities. It's the same process, over and over. I didn't give you that many to do because I know they're all involved, but you have to do them.